expert from the Fermi Energia, Mr. NURMEOJA, Project Director.
Yes, good morning. I will give a short overview of the SMR deployment program in Fermi Energia. And of course, first I introduce myself. My name is TEET NURMEOJA, and I am a project director. And I have a mechanical engineering background. And I worked before in Sweco project, in Vopak EOS, in Pak Terminal, Millstrand, and Scanveld. So, already 2020, Fermi Energia carried out SMR feasibility study with several national and international partners. One part of our study was the nuclear power plant site screening. With the use of good partners like Tractable and Steiger, we were able to down-select the 5-6 locations. And we report pointed out that the most suitable places will be Kunda or Aidu area. And based on early location selections, in 2022, Fermi Energia ordered geological and hydrogeological research works from Steiger. There is less geological information about Kunda area than Aidu area. We decided to first explore the Kunda area. And the physical executions of the works was postponed in many different reasons to the winter, as you see on the picture as usual. So, but the purpose of research work is to make preparations for nuclear power plant foundation design works as early as possible. And it is also provide a better budget overview for site-specific underground works in the future. And the report with the foundation sketch design will be ready in June 2023, so soon. As mentioned before, in early spring 2023, the Government Nuclear Energy Working Group published the report of nuclear power plant and spent fuel final storage location spatial analysis. And as we saw before, the analysis identified 15 different sites. We are happy to note that some selected areas by the Nuclear Energy Working Group are the same as results of Fermi Energia study with partners. So the again overlapping regions are Kunda and Aidu. So and next, in 2022, in the summer, Fermi Energia ordered nuclear power plant layout sketched and visualization from design company Sweco project. The layout is necessary to know the size of a planet area, and it's also input for national designated spatial planning. And in our case, the planet area is about 60 hectares, and the layout sketch was made for 2 locations, again, Kunda and Aidu. So, as already told, in February 2023 took place the selections of a technology supplier. The winner was GE Hitachi with PVRX 300. And important to note that the reactor building is located about 35 meters underground, and for safety, the above of the reactor is a passive cooling pool with cooling systems. Yes, next. Now the technology is selected, and we are currently solving the two specific topics, like residual heat cooling solutions and electricity grid connections. The first selections of cooling solutions available options are: is it direct cooling, mechanical draft cooling with the towers, or hybrid closed-loop cooling systems, etc. So research work for this will be ordered soon. And second, as I mentioned, electricity grid connections, we have regular technical consultations with Elering. And the main topics are how to integrate nuclear power plant to the existing grid. And final information was that the technical conditions from Elering will become in the second part of this year. So Fermi Energia and GE Hitachi signed the early works agreement on 8th of May 2023, so less than 1 month. And our next steps is the first, finding a parties of a contract, like a main constructor, architect engineer, and second, development of a contract model. Can we use traditional EPC, or it will be integrated project development, like EPD model? When we will continue the localized budgeting, if the partners will be selected, we will renew the time schedule. After that, licensing and PSAR, and when preparation of natural designated spatial planning, then human resource and training development, etc. So duration of agreements with GE Hitachi is until 2028. So there is plenty to do, but the good planning and preparation is a key to the success of a project. So, and finally, we will build Estonian clean energy future. And here is our team. Thank you.
Thank you very much. Thank you very much. So, are there any comment, question? No? Yeah, yes, Ina-san. Yes.
Thank you very much for the explanation and the recent the situation of the installation of the SMR in Estonia. My question is, there are many candidates, SMR suppliers, to intend to cooperate with Estonia, but you decided on the BWRX-300. What is the point to select the BWRX-300 to install the Estonia?
So we had in last year in September we sent out the invitation to participate in the different technologies, and it was 3 companies. It was GE Hitachi, it was Rolls-Royce, and it was NuScale, exactly. And reports and explanations came at the end of the year, and after that we take 1 month to select of a winner. And the decisions made by this, that we decided that GE Hitachi was maybe most reliable technology for this, that the NuScales and the Rolls-Royce have some points that is they are not ready to go in the market, so it was too fresh or too early. And the decision, main things was, yes, the technology, maturity for GE Hitachi showed us for this. Sorry.
Just to comment on the same topic. So yeah, we did a very thorough technology review. So first of all, of course, we looked at the technology aspect, like the safety of the plant. We did quite well in-depth safety analysis already with our international partners already beforehand of this analysis. Then we looked project implementability, like how are the reference projects going on? Because for us, it is very important that in Estonia, we will not do a first of a kind. It is very important that there is somewhere in the democratic Western world actual plant going to be built, and it is going to be built with a high certainty. So there was a lot of different aspects. We also considered what are the options for Estonian companies or Estonian supply chain to involve if we compare different reactor types. And of course, in the end, the third big part was all the financing and financial part. What's the cost? What are the different financing options? And so we looked at a lot of different aspects. And I think one of the key element why actually GE Hitachi was chosen was that the reference project in Canada is going ahead strong. OPG, Ontario Power Generation, as a government or the state company, has a very strong background, so they have a very reputable track history with the operating nuclear power plants. They have a good team with who they have been cooperating. The ACON, the main constructor, SNC-Lavalin, and yeah, the GE Hitachi. So they have formed this integrated project delivery team who will deliver this first reactor, and actually then they are planning to build a second, third, and fourth one. So one site, 4 reactors in Canada, and we are really closely observing that. And actually, some of our team, we were in Canada a few weeks back, and we saw the site is actually, the earth is being removed, so they are preparing the site for the first unit. And in addition, also, like boiling water reactor is a simple reactor, and we have very good experience from our neighbors, from Sweden and Finland. So there is expertise and very good track record. So this is kind of the reasons why we went with this technology. Yes.
Yeah, thank you, Henry.
Any other more comment? Question? No? Thank you so much.
Thank you.
Thank you.